In this video, we are going to solve the problem number 1.74 from Irodov. So let us first read out the problem and then we will solve the problem step by step. In the arrangement shown in figure 1.17, so this is figure 1.17, the mass of the rod M. Here we have the rod and it has the mass capital M exceeds the mass M. So this is the ball that is of mass smaller m, and this capital M is more than this mass of the ball that is smaller m, and the ball has an opening permitting it to slide along the thread with some friction. So basically there is an opening in the ball and through which the thread is passing through, and there is the friction between the mass m and the thread. The mass of the pulley and the friction is in its axle are negligible, so there is no friction between the axle and the thread, and the mass of the pulley and the thread is also negligible. The ball was located opposite to the lower end of the rod. So basically initially this particular ball is located along the lower end of this rod. When set free, both bodies begin moving with constant accelerations. Find the friction between the ball and the thread. If t seconds after the beginning of the motion of the ball got opposite the upper end of the rod. So basically it is asking what is the friction force between mass m and the thread, so that in time t it is reaching to the opposite end of this rod of mass m. So let us first draw the free body diagram of the rod. So this is the rod, and in the downward direction we have the gravitational force, that is capital Mg, and in the upward direction we will have the tension force due to the thread. And let us assume that we have the acceleration in the downward direction, that is a capital M. So using this free body diagram, we can write capital Mg minus tension force is equal to capital M into Am. So this is the first equation we are having. Now let us draw the free body diagram of ball. So this is ball, and it will have the gravitational force in the downward direction, that is smaller mg, and there is the friction between this ball and the thread. So as it is moving in this direction, so we will have the friction force in the upward direction, let us say capital F. And let us assume that it is having the acceleration in this direction with the acceleration of a small m. Now if we write the free body, if we write the equation, then we can write small mg minus friction force is equal to mass into acceleration. Okay. Now if we see, we have the uh, variables here, that is am, and here we have the variables that is smaller am, and we have the variables capital F and this tension force. Now let us draw the free body diagram of this thread. Let us cut the thread from here maybe. So if we draw the free body diagram of the thread, then we will have the tension force here, and because of the friction between ball and the thread, we will have the friction at this point in the downward direction, that is capital FF. So from here we can write tension force minus capital FF is equal to mass of string into acceleration of mass m. But we know that the mass of string is 0, so this term will be 0. So finally we will get tension force is equal to friction force. This is the third equation we are having. Now we can substitute this third into first equation, because finally we want the friction force. So we can write here capital Mg minus friction force is equal to capital M into A capital M. Let us say this is fourth equation, and let us rewrite second equation here. So we will get smaller mg minus capital FF is equal to small m into am. Let us consider this as 5 equation. Now here again we have the three variables, that is capital FF and AM and this AM. So we should have another equation to solve these two equations. So in the problem it is saying that in time t, the mass m is moving from this particular point to this particular point relative to the motion of the thread. So in that case what we can write? We know from the equation of motion that S is equal to ut plus half at square. So initial velocity is 0 and S is the length of this rod. So we can write L is equal to half into what is the relative acceleration that we know, that is A capital M minus A small m into t square. So from here we can get A capital M minus A small m is equal to 2L divided by t square. So this is one of the equation we got. Now we have to use this particular equation to solve these two equations. So if you see here, we have capital M and small m here. In order to get this, we should have the coefficient of this A capital M and A smaller m should be same. So let us multiply this equation by smaller m and this equation by capital M. So from here we can get capital M small m into G minus small m into capital FF is equal to capital M small m into AM, and the second equation we will get capital M small mg minus capital M into FF is equal to capital M small m A smaller m. So let us subtract these two equations. So we will get, this will get cancelled and then we will get minus m plus capital M into FF is equal to mm into am minus am. And from here we can get the value of A capital M minus A smaller m, that is 2L upon t square. So we can write capital M minus small m FF is equal to mm into 2L by t square. So from here we can write friction force is equal to capital M small m 2 times L whole divided by capital M minus smaller m into t square. So this is the value of friction force that we got. Okay, I hope the problem is clear. Thank you.